Hey there everyone, welcome back to Leetcoding. In this video we will be solving the question number 3 of Leetcode bi-weekly contest 40. Name of the problem is designed front middle back queue. The problem description is we have to design a queue that supports push and pop operations in the front, middle and back. So we have to implement the following functions which are given to us. Let us first see what a queue is. So when we insert into a queue, let's say if we have a queue like this and we are inserting an element into the queue. So let's say this is the first element and this is the second element. So 1 is the first one that will be popped out and then 2 will be popped out. So this is the basic implementation of a queue. Now for the purpose of inserting at the front and then removing from the front and inserting at the back and removing from the back in constant time, we have another data structure called deck, and those who don't know about deck can search the same on c++.com. So here's a entire information about the deck data structure. In this data structure you can insert at the front and at the end in a constant time and remove from the front and from the end in a constant time. But there's another operation that we have to handle, and that operation is to insert at the middle and remove from the middle. Now what we can do is we can create two such data structures, two such decks. So this is the first deck, this is the second deck, and let's say n1 is the size of first one and n2 is the size of second one. Initially both of these are 0, so d1 represents the first deck and d2 represents the second deck. Now let us say we have to insert an element at the front. So we will be inserting, so we will first of all we will consider these two deck as a combination of these two deck as one single deck. So whenever we want to insert some element into this deck, we will be inserting in the first deck, and that also at the front. So let us say the first element is 1 and 1 will be inserted in the first deck at the front. Now n1 will be increased, n1 will be 1. Now let's say we have the second element. The second element is 2 and we have to insert 2 at the end of the queue. So at the end, this is the end, and we have to insert from the end, so we are inserting, but then nothing is there in this second deck, so eventually this 2 is going to come at the front and the size of this will increase now, and 2 will be equal to 1. Now let's say we have another element, the element 3, and we have to insert the element 3 at the middle. So when we have two elements, let's say 1 and 2, we can insert 3 in the middle. So for that what we are going to do is we are simply going to insert 3 into the first deck, and that from the end. So 3 will be inserted from the end. Now the size of n1 will be 2. Another thing that we have to maintain is the balance between n1 and n2. Now let's say we have another element, that element is 4 and 4 is being inserted from the front, so that will be inserted from the front, so 4 will be inserted here, but then the size of n2 will become 3 and there will be a disbalance. So we can give priority to the deck 1, but we can only have one extra element than the deck 2 and not more than that. So let's say 4 is coming here, so the total number of elements in the first deck becomes 3. The total number of elements in the second deck is still 1, so we cannot have a difference of 2. We can have at most the difference of 1. So now as the difference is increasing, what we are going to do, we are simply going to remove the last element, that is 3, from the back of the deck 1. So we are going to remove 3 and we are going to push 3 into the second deck, that is from the front of the second deck. So 3 will come here and 4 will be inserted into this, so the final configuration will be 4, then 1, then 3 in the second deck and 2 in the second deck. So this is how we have to balance the size n1 and n2. Now let's say another element is coming, that element is 5, and 5 is to be inserted in the middle. So whenever we want to insert an element in the middle, we are going to insert it into the n1 first. but the uh, as the total number of element is 4, so 1, 4, 1, 3 and 2, 5 will be inserted here, and we can insert 5. And if we want to remove an element from the middle, we can simply remove it from the back of n1. Alright, so we can see few examples here. This is another case that we have to handle, that when the total number of elements are odd, then in this case the element which comes in the middle will be in the side in the side of n1 or the deck 1. Similarly, while popping, we should be popping, if the total number of elements are even, then we should be popping the element from the end of deck 1. Now things will become more clear when we start coding this approach. So we can jump to the code. So while writing the code, if there is something that I have to explain, I will come back to that. First of all, we are creating two decks of type int d1 and d2, then two variables, integer variables for size n1 and n2. Now in the constructor, I'm going to initialize this, the size of first deck n1 as 0, the size of second deck n2 as 0. Now when we are pushing at the front, this is the first operation, push front. So what we have to do is we have to simply push into the first deck, and then we will see if there's a disbalance in the sizes. So first of all, we are simply going to push into d1, push front the element, and then if n1 is equal to n2, if both of these the sizes of both of these decks are equal, then we are simply going to push into the first deck because we are giving it the priority. Otherwise, what could be the other case? The other case could be when the size of n1 is already greater than n2. So in that case, we have to push one element into n2 so as to balance the size, one element into deck 2 so as to balance the size. Now for that, what we can do is, so let me draw that configuration and explain. What we are saying is, this is the deck 1, this is the deck 2, and two elements are here, and there's no element here, and there's only one element here. Alright, so this is the configuration that we are going to tackle now. There comes another element 3, and we have to insert this element. Now as we have to insert this element at the front, we will have to insert it into the deck 1. So we will have to insert it here, 3 will be inserted here, but then there's a disbalance in the size. So in order to balance that, what we can do is we can simply remove the element 2 from the back of the deck 1 and insert that element 2 into the front of deck 2. This will not disturb the configuration. So which element did we remove? I think 2 and 1 here. So this will balance the size. That is what we are going to do here. Otherwise, simply push back into d2, push front into d2, d1 dot back, and remove from d1, pop back, and we have to increase the size of the second deck. So coming to the push middle, in this also, if sizes are same, n1 is equal to n2, then what we have to do is, so if these sizes are same, we can simply insert the coming element, let us take this element as 5, into deck 1, so we can insert it here. But in case the size of n1 is greater than the size of n2, So the configuration is 3, 1, 5, 2 and 1, and as it is given here that whenever such an element comes, so that should be inserted at the side of n1. So for that, what we have to do is we have to shift this 5 to deck2 and then insert the coming element at this position. So let us say the coming element is 6, so we have to remove 5 from here and put 6 here, and then shift 5 to the deck2. Okay, now we can code the same. If the sizes are same, then we don't have any problem. We can simply push at the back of deck 1 and n1 plus plus. Otherwise, d2 dot push front one element from d1 dot back, and d1 dot pop back. Now we can insert this element, so we can insert it into d1 dot push back this value and n2 plus plus, because eventually the size of deck 2 is increased. Next operation is the pushback operation. Now in the pushback operation, we have to push from the back, and that means we have to push at the back of deck 2. So if n2 is smaller than n1, then we don't have any problem. We can simply push at the back of d2. So d2 dot pushback this value, and if the size is smaller, then we don't have to make any changes, simply increment n2. Otherwise, if the sizes are same, then in this case we have to remove one element from the front of deck 2. So let me draw that as well. This is deck 1, this is deck 2. 1, 2, 3 and 4. Now if we want to insert an element at the back, we can insert it from the back here, but now the size of n2 is greater than n1, which we cannot allow. We can only allow n1 equal to n2 or n1 greater than n2, but here n2 is greater than n1. So in this case what we have to do in order to balance sizes, we have to remove the front element from the deck 2 and push it at the back of deck 1, and then change their sizes. So now n1 and n2 are balanced. This is equal to 3, this is equal to 2, which is the balanced condition. We have already inserted. Now what we have to do is we will have to push into d1 from the back. So push back d2 dot front and d2 dot pop front n1 plus plus, because eventually the size of n1 is incremented. Now coming to the pop operations. Pop front. If n1 is equal to 0 as well as n2 is equal to 0, what does it mean? It means that both of the decks are empty and we have to return 0. I think -1, yeah, you have to return -1 in this case. Otherwise the answer will be the front element, that is d1 dot front, and we have to pop it, so d1 dot pop front n minus minus, n1 minus minus. Now if n1 is smaller than n2, now this configuration is not allowed, because we have already discussed that n1 could be greater than or equal to n2. So we have to balance it now. In order to balance it, we have to transfer one element from deck 2 to deck 1. So d1 dot pushback d2 dot front and d2 dot pop front n2 minus minus and n1 plus plus, and then return the answer. Now we are popping from the middle. As we already discussed that whenever we are popping from the middle, we should be popping from the back of n1. Now the base condition going to remain same, that is if both of them are empty then return -1, otherwise answer is equal to d1 dot back and d1 dot pop back. Now this could also disturb the equilibrium between n1 and n2. So if n1 becomes smaller than n2, then we have to again balance them. So in order to balance them, we have to insert one element from the front of d2 to the back of d1. Pushback. Alright. d2 dot pop front n2 minus minus and n1 plus plus, and then return answer. Each of these operations are constant time operations. As you can read about DEX here, all of these functions, the push front, the pushback, front and back, all these are constant time operations. Now coming to the last operation, that is pop back. Again, if n1 is equal to 0 and n2 is equal to 0, return -1. In this case, we have to take the element from the back, so answer will be equal to d2 dot back and d2 dot pop back and 2 minus minus. If now we have removed one element from the back of deck 2. So let's say this was the configuration and we are removing the back element, that is 5. So this is removed. Now again there's a disturbance in the equilibrium because n1 is equal to 3 and 2 is equal to 1. The difference between them is 2, which is greater than 1. So now we have to again make changes so that we can attain back our equilibrium. So we have to remove one element from the back of deck 1. So we can remove 3 and we can insert 3 at the front of deck 2. Insert 3 here. So if n2 plus 1 is smaller than n1, then d2 dot push front, d1 dot back and d1 dot pop back, n1 minus minus n2 plus plus, and return answer. Now there's one more thing that we have to handle in the pop back operation. So let's say when we are popping the next element 4, so this will be the configuration. Again this is not disturbing the equilibrium because n1 is equal to 2 and 2 is equal to 1, so the difference between them is 1, so it is not disturbing the equilibrium. So we are again popping back another element from the back, so it will remove 3. Now it is disturbing the equilibrium because now n2 becomes 0 and the difference becomes 2, so we have to remove an element from here and we have to insert it here. Now again popping back, we will be popping this and it is not disturbing the equilibrium. n1 is equal to 1 and n2 2 is equal to 0. So the difference is 1. But now when we are going for the popback operation, as we have one element in our entire structure, so this is our entire structure, the combination of these two, and when we are removing one element from the back, we are always taking it from deck 2, but there's no element in deck 2. So we have to handle this case, because in the entire structure we have one element that we can remove. So that we can handle if n2 is equal to 0, if the second deck is empty and there's some element, and there can only be one element in the first deck, so our answer will be equal to d1 dot back, or we can take it as d1 of front as well, and d1 dot pop back, n1 minus minus, and return answer. Let us try to run this. I think it is giving correct answer. Let us try to run this on. Okay, there's only one test case. Let us submit this now, and it got accepted. So for n elements, n operations, it is going to take big O of n time, and for each operation it's a constant time operation, and we are using big O of n extra space here for n elements. So this is it for the solution. If you like the video, please subscribe to the channel. Thank you.